from Open Grid Systems, and we're going to look at how we can create a simple test network using Cimphony when we have no existing data and we're going to be doing it from scratch. The window here is what you'll see when Cimphony is first opened up. We have no projects at the moment and no networks. The first step is we'll create a Cimphony project. Anybody that has used Eclipse should be familiar with these dialogues. We'll give this project a name and we'll call it example, and we'll put it into the default location within the workspace. So we now have our example project created here with a couple of subfolders created where we could put incremental and network files. First thing we're going to do now is just create a blank Cimphony resource. Move this down. We'll put it within our network here. We will call it test, and we'll give it the extension .xml. For this purpose, so we can view the sample data afterwards, we will leave it as the sim rdf xml, and this will create it as a single file. There are some additional options for what you can serialize them as, but we'll leave it as RDF because that is most familiar to people that are used to the sim. When we create this, it now loads up here within the browser view, and it's currently empty. This is just, at the moment, an empty RDF file. We have not selected a meta model, so we've not selected the version of sim that we're using. The first thing we'll do though is we'll add in a geographical region. As you see here, no meta model selected, so we will select Sim 15, which is the most recent one that's just gone to IEC. We'll find geographical region. We just want one instance to be created, and the documentation here, when you select the class, shows you what was within the IEC standard for describing it. So now within our model here, we have our geographical region. Then if we click on the instance, we can see the properties that are available for it. We could give it a name. The UUID here is a unique identifier for this object that is generated by Cimphony. So we can give it a name, and we will call this Scotland. So our geographical region now is called Scotland, and that is all that is filled in. You can see here there's other associations it could have that are blank, but for the moment we'll just leave this as being a blank geographical region. We're going to create some sample data here, and what we're going to use is the geographical editor that is built into Cimphony. So here we have the Open Geospatial Editor using Google Maps. We will select our independent resource here, which is the test.xml. The coordinate reference system, Cimphony supports a number of coordinate reference systems, but we will be using the default WGS84, which is most commonly known as latitude and longitude with decimal degrees. These are just the defaults at the moment. For the Google Maps view, you can't change these. We will allow the editing, and we will allow placement. So now this changes the perspective, and what we have loaded up here is just a blank map and our original file at the side here. So what we can do is we can zoom in and decide where we want to. We can double click as well. We can decide where we want to place our network. So if we zoom in here to Scotland, we can decide that we want to place some substations. We have some templates down the side here. So we have our medium voltage, low voltage to medium voltage substation, and extra low voltage to low voltage substation. These are just sample simple templates that we have added in to allow us to do placement. So we will decide we're going to place an MV substation, and we will put it down here around about Carlisle, and this can represent the interconnection with England from our point of view here. We double click, we want to give this a name, so we will call it National Grid. I will call it National Grid A in case you wish to add in a second one. So this is now added in our substation here, and you can see in the browser view here we have suddenly populated a lot more sim components. We have our substation. If I expand this out, you can see it's called National Grid. If we turn off all empty attributes and empty associations, it simplifies the view. So this is a single voltage level, which is MV. It's base voltage. For this purpose, we've made it 33 kV. The voltages that we're assigning here are more distribution than transmission. And it has within it a bus bar section and a connectivity node. We could decide we wish to add in an LV to MV substation and put it here around about Glasgow. So we double click and we will call this Glasgow. And you can see the icon is slightly larger and it has two colours which represents the two voltages now. If we look at the Glasgow substation that's been created, we have two voltage levels for the MV and LV, and the base voltages for one 33 kV, the other one 11 kV. The next step is we wish to add in a line to connect them, so we click on the add line. When we hover over here, it will show us what the connections available are. At the moment this is just picking it from connectivity nodes that have bus bar sections. So we may decide we wish to do this. We have to pick the 33 one here. If we select the 11, it won't let us connect to the 33 down here. So we start at the national grid, we can demonstrate that. So we've selected the starting point there, and if we double click and double click, we can add some line routing in following the M74 motorway. And then when we arrive at Glasgow here, well, if we select the 11, it pops up an error message. The source point is 33, the end point is 11, so it's not allowing us to connect between voltage levels. So instead, we will select 33. We'll give this a new line and we'll call it the north-south interconnect. So this has now added our line in. You can see it's auto-coloured it based off of the voltage. We have our line, which is north-south interconnect. And within it we have a single AC line segment. It has two terminals. We have the location information here, including all of the 6 position points representing the bend points and the end point, and a coordinate reference system which is using the OGC URNs to describe it as being the WGS84. So that's now have our two substations added in. The terminals, connectivity nodes, all of the SIM connections are added in automatically in the background. So we could then, because this is Google Maps, we can zoom right in. We could turn on the satellite view if we wished. So as we get further in, we can see where we've placed it. We may decide this isn't actually where we wanted it, and we can drag and drop the substation and it will update the location information. And we could decide we wish to, now we're in here, we could add in another substation, make it a low voltage substation. So if we select a low voltage substation, we can double click and we'll call this one just example sub. Once again, we can add a line in, double clicking to add in bend points and connect them up, and we'll just leave that as new line here. As you zoom out, it groups the icons together, so we know there's two substations within here. As we zoom in, it'll separate them out. The reason for this clustering is that when you get to very large networks, having several thousand icons on the screen is unreadable, and so it shows you how many is in that area. As you get to lower zoom levels, the resolution gets better, and down at the lowest levels it renders all of the icons. So this has built up our very simple model at the moment. Of course, one of the things it's been doing though is adding in base voltages all of the time, even though that they're not checking for the duplicates. What we can do is there is a command that we can run, which is in the resource menu, which you cannot see. But this will merge base voltages together. We say yes, we wish to continue, and what it does is it groups them together into one of each. So that allows us to clean up the model after we've been doing the creation. So at the moment, this has not altered the file on disk. Everything that's been done is being done in memory. We can click save, and that updates our test.xml. If we move back to the Cimphony view, the layout changes. We can take our test one, and we'll refresh just in case it's not done that. And if we open it with a text editor, we can see the sim RDF XML that has been created, and with all of the associations, unique IDs, and that for Sim15, and follows the IEC 61970-552 RDF format. So that's a very simple example of how we can use Cimphony to create a network from scratch using the Geographical Editor.